Welcome back to lesson 18, where we are going to solve more problems about series. We are going to see geometric series basically. We are going to apply our knowledge that when the r in a geometric series is less than 1, converge. When it's bigger or equal to 1, diverge. Well, let's go to practice these problems. 10 problems. Practice 1. Problem 1. It says verify that this series diverge. How we can verify that this series diverge? Well, we can make the sum or from n equals 0 to infinity to realize that if we write some terms, the series will diverge. So let's go to write some of the terms. So the sum is from n equals 0, so it would produce a term that is a0, and a0 will be 1. When n equals 1, a1 will be minus 5 divided by 3. a2 will be minus 5 divided by 3 square. And a3 will be minus 5 divided by 3 cube. This is plus 5 divided by 3 square. And this is equal to minus 5 divided by 3 cube. Okay. So what is the sum? The sum S1 is 1, or S0 in this case. S0 is 1. S1 is A0 plus A1 is 1 minus 5 divided by 3. S2 is 1 minus 5 divided by 3 plus 5 divided by 3 square. S3 equal 1 minus 5 divided by 3 plus 5 divided by 3 square minus 5 divided by 3 cube. So now we can do two things. We can keep going and making the sum and realizing that the sum will not converge to any number, it will go higher and higher and higher, or we can say the following thing. This is a geometric series when the r is minus 5 divided by 3. Minus 5 divided by 3 is the number that you have to multiply the previous term to obtain the following term. So if you multiply minus 5 divided by 3 plus multiply by minus 5 divided by 3, you will obtain this term, 5 divided by 3 squared. If you multiply this term by minus 5 divided by 3, you will obtain this one. So we have we have learned from a geometric series that when the r is less than 1, the geometric series in this case converge. The geometric series converge when r is less than 1. So it means that r is between 1 and minus 1. And when the r is bigger than 1 and the r is smaller than minus 1, so the series converge between 0, 1 and minus 1 in this interval. Because you are 5 divided by 3 minus 5 divided by 3 is here, the series diverge. So the series, because r equal minus 5 divided by 3 is r is smaller than minus 1, means that is at the left side of minus 1. Then the series diverge. This is an alternated series, and an alternated series to converge, it needs to happen two things. One, the limit of a sub n goes to 0 when n goes to infinity. So this is the test for convergence of an alternative series. This is an alternative series. This is positive, negative, you see? Positive, negative. So this is an alternated series. We will see very soon that the test for convergence for alternative series need to happen two things. The first thing is the limit when n goes to infinity of a sub n goes to 0. Who is a sub n here? A sub n is, this is minus 5 divided by 3, minus 5 divided by 3 to the n, and this limit doesn't go to 0. Because when n goes to infinity, this 5 divided by 3 will go to infinity. And the second condition for an alternative series to converge is that the a sub n plus 1 is smaller than the a sub n. The terms are decreasing. Okay, let's go to the next problem. The next problem says verify that the series diverge. Well, this is the test for divergence. The test for divergence, it's if you have the divergence, you say if you have a series where the limit when n goes to infinity of a sub n doesn't go to 0, the series diverge. So we need to do the limit. So a sub n, in this case, a sub n is n divided by 2n plus 3. And when n goes to infinity, the limit when n goes to infinity of a sub n, it goes to the limit when n goes to infinity, it goes n divided by n, 2n divided by n, 3 divided by n. It will go to 1 divided by 2, plus when n goes to infinity, 3 divided by n goes to 0. So it will go to 1/2, and because 1/2 is not 0, it doesn't go to 0, the limit, the series diverge. This series diverge. You have to take a note that this theorem means that the series diverge. It means that is a condition if a sub n doesn't goes to 0, the series diverge. Let's go to write it. If limit of a sub n of a sub n doesn't go to 0, the series diverge. Problem 3. Verify that the series summation from n equals 0 of n factorial divided by 2n diverge. Well, if a sub n doesn't go to 0, the series diverge. The series diverge because you are summing terms that are not going to 0, so you cannot stop at any fixed number. So the summation, so a sub n is equal n factorial divided by 2 to the n. How will make the limit when n goes to infinity of this fraction, of this relation? Well, n factorial will grow up faster than 2 to the n. When n goes to infinity, this ratio will be n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3, etc. So if n goes to infinity, n is infinity. It starts at the infinity, while 2 to the n will be 2 by 2 by 2 by 2. So you see that the ratio of one term divided by the other term, you see that this ratio n divided by 2 goes to infinity. N minus 1 divided by 2 goes to infinity as n goes to infinity. N divided by 2 divided by 2 goes to infinity, so it will be the product of many infinity. So this will go to the infinity, so these limits will go to infinity. And let's go to do the next problem. Problem say, find the sum of the convergent series 0.7 divided by n, 0.9 divided by n. So the summation of from n equal 1 to infinity. So first of all, we realize that here there are a geometric series. We realize that 0.7 is the same that 7 divided by 10. And 0.9 is the same that 9 divided by 10. So we are dealing with two geometric series with the r of the one of the geometric series 7 divided by 10, which is less than 1. And the other r of the geometric series is 0.9, which is 9 divided by 10, which is also less than 1. So we are doing the sum of a geometric series that will converge because the r is less than 1, and subtracted the series of another geometric series that will converge because the r, this 9, 10, is less than 1. So we can do this sum. We can do the first sum for this geometric series. We can do the second sum, and we can subtract. Now the summation starts at n equal 1. I want to displace this summation from n equals 0. If I displace from n equals 0, you see 0.7 raised to the 0 is 1. But 0.9 raised to the 0 is also 1. So 1 minus 1 is 0. So I have not altered the sum if I start the sum from n equals 0. Now I can apply my formula for a geometric series, and the formula for the geometric series is that 1 plus r squared plus r cubed plus r to the n, etc., the sum s is 1 divided by 1 minus r. So I will do the sum of the geometric series will be 1 divided by 1 minus r. The sum of the other geometric series will be 1 divided by 1 minus 9 divided by 10. I might have to subtract the sum of the first geometric series from the second. So it will be this minus this. This is 10 divided by 3, and this is 10. 10 divided by 3 minus 10 is minus 20 divided by 3, and the problem is solved. This problem is exactly the same problem than before. We have two geometric series. The R of this geometric series is 1/2, which is less than 1, meaning that the geometric series will converge. The R of the other geometric series is 1/3, less than 1, it will converge. And for each one, I can apply the summation when n goes to 0 to infinity of r to the n. What is this? Is 1 plus r squared plus r to the n. And what is this sum? Is 1 divided by 1 minus r. This is the sum. So we apply this sum that we have deduced in previous lectures, and the sum will be 1 divided by 1 minus r. And the other one would be 1 divided by 1 minus r. I make the subtraction, and I will have to find 1/2. Let's go to the next problem. The next problem say, find the sum of the convergence series 1 plus 0.1 plus 0.1. Which number will represent this number? It will represent the number 1.11111, because if you make the sum of 1 plus 0.1 plus 0.01, it will be 1.11. Okay, 1 comma, 1 point, whatever. So, but this series is a geometric series. How you realize that it's a geometric series? If you multiply by 1 divided by 10, the 1, you will obtain 0.1. If you multiply by 1 divided by 10, 0.1, you will obtain this one. If you multiply 1 divided by 10, this term, by 1 divided by 10, you will obtain this one. So the series is a geometric series. So if I want to make the summation of this series, easy. 1 divided by 1 minus r. 1 divided by 1 minus r, the summation is 10 divided by 9. What it means this? It means that the number 1, this is 10 divided by 9. If you divide 10 divided by 9, it will give you 1.1111 or 1.11. Repeat it. Let's go to the next problem. Say, what it say? It say, find the sum of the convergence series sine 1 to the n. What is sine 1? Well, 1 what? 1 degree, 1 what? Should be the one that is here. The one should be 1 radian. Should be 1 radian because sine of something, the something doesn't have any units. So 1 radian is the angle theta. 1 radian is the angle theta that when you walk through a circumference of radius 1 meter, if you walk the arc length here, how much it is? How much it is? You know, is 1 meter. So 1 radian is when you walk through here 1 meter through a circumference of radius 1 meter. So the expression, the equation for defining theta in radians is that theta is L divided by r. Theta is L divided by r, and theta have no units. You see, meters divided by meters have no units. Now, 1 radian corresponds in degree to 360 divided by 2 pi. So 1 radian the corresponding degree for 1 radian is approximately 56 degrees, something like this. This is approximately 1 radian. Okay, so we have sine of 1. Sine of 1, the problem say, find the sum of the convergence of sine of 1 to the n. So it's sine of 56 degrees, which is positive, sine of 1 radian to the n. So this is positive, is a geometric series, so the summation from n equal 1 to infinity of sine of 1 to the n is, from n equal 1 is sine of 1. From n equal 2 is sine of 1 is square. From n equal 3 is sine of 1 cube. Oh, I see the geometric series, sine of 1 to the 4. So what is the r of this geometric series? The r is sine of 1. And what is the infinity sum of this series? The infinity sum, because it's a geometric series, is 1 divided by 1 minus r. So it's 1 divided by 1 minus r. And r is sine of 1. But we need to be careful with this. When you do this formula for a geometric series, is 1 plus r squared plus r to the n, and keep going to the infinity. This is 1 divided by 1 minus r. But the equation that we have is start at r. So this formula is not true for this case. What we have sum is everything. So from here we need to subtract 1. Let's go to do it. So the sum of this geometric series is indeed, let's go to erase here, is, let's go to leave it here, plus r squared. So this is r plus r squared plus r to the n, keep going, is 1 divided by 1 minus r minus 1. So this sum r plus r squared plus r to the n, and keep going to the infinity, is 1 divided by 1 minus r minus 1 minus r divided by 1 minus r. Oh, this sum now is 1 minus r. Now 1 minus 1 is r divided by 1 minus r. Because, and now I have the sum that they are asking me. So the sum that they are asking me is r divided by 1 minus r. Who is r? Sine of 1. 1 minus sine of 1. Now if you go to your calculator and you find sine of 1 radian, not sine of 1 degree, sine of 1 radian is sine of 50 something. Sine of 50 something maybe is 0.7, maybe, I don't know, you will do it 0.7, something like this, divided by 1 minus 0.7. And the problem say that this is 5.3. Okay, maybe, you do it. Okay. Well, I have checked sine of 1. Sine of 1 is 0.84. Is 0.84 divided by 1 minus 0.84. So this will be 0.84. 1 minus 0.84 is 0.16. And now should be correct. Now let's go to do this problem. It says the summation from n equal 1. The summation from n equal 1 to infinity is natural log of 1 divided by 1 plus natural log of 1 divided by 2 plus natural log of 1 divided by 3 minus natural log of 1 divided by 4 and keep going forever. So the natural log of 1 is a function like this. Natural log of x is a function like this. When it's 1, it's 0. So this is 0. When it's 1/2, it's something negative. When it's 1/3, it's something even more negative. 1/2, 1/3, etc. So as you're going, then a sub n, the last term will go to the infinity. So the series diverges because the limit when n goes to infinity of a sub n, or the limit when n goes to infinity of the natural log of 1 divided by n goes to infinity. And because these limits, the a sub n goes to infinity, the series diverge. Okay. Is this a geometric series? No, there is no any number that I have to multiply the previous one to obtain this one. Not the same. Okay, and what is here? The series diverges because natural log doesn't tend to 0, natural log, okay. Okay, this is the solution. Okay, to the next problem. It says find all values for x for what the series converge. Okay, so first of all we write the terms. The first term will be x minus 1, 1. The second term will be x minus 1 squared. The second term, it will be x minus 1 cubed. And keep going to the infinity. Is this series a geometric series? Yes. What is the R of the geometric series? The R is the number that I have to multiply the previous one to obtain the next one. What is this number? It's x minus 1. If I multiply x minus 1 by x minus 1 squared, I will obtain this. If I multiply the R by this, I will obtain the next one. So this is a geometric series. When a geometric series will converge? It will converge with the absolute value of R is less than 1. Or in other words, when the absolute value of R is x minus 1, is less than 1. Or in other words, when x minus 1 is less than 1 and bigger than minus 1. Or in other words, when x is smaller than 2 and bigger than 0. So the radius of convergence is here. The problem is solved, so it means that this geometric series x minus 1 to the n will converge on the interval 0, 1, 2. It will converge in the open interval 0, 2. 0, 0, 2, 0, 2, 1. It will convert and is centered at x equal 1 and will diverge and converge here in the open interval. The 0 and the 2 is not included. At 0 and 2 will diverge. You can check it. Okay, let's go to the next problem. There is no more problem here. Oh no, there is more problem here. It says a ball is dropped from the height of 16 feet. Is time that it dropped 8 feet, it rebounds 0.81 h. So find the total distance traveled. So I think I did this problem at class. Let's go to do it. I think this is the ball. The ball goes up, goes down, goes up, and goes down, goes up, and later on goes down. So he performed 60 meters of distance, 60 meters of distance, plus. Now he will go up 0.18, 0.18, I think that you say. He performs 16 meters going up and 16 meters going down. I'm going to consider only the up, and I multiply by 2. So it will be, now on the next step, he will advance up 0.81 times h, plus h is the 60. So it's 0.81 by 60. Now on this third step, so it's 0.81 of 60. Let's go to put it here, 16, okay, of 60. Now on the first step, he goes and he advances up again 0.81 of the previous height plus 0.81 of the previous height. The previous height is 0.81 h. And now on the following step, he will advance the amount 0.81 of the previous step. The previous step, the previous height is this one, is 0.81 by 0.81 h. So what I have here, I have the sum, so this will do it infinity times, and eventually will stop. Eventually will stop. This is eventually the position will be at the floor. This is a good question. So the sum will be 16 plus 16 multiplied by 0.81 plus 16, this is the previous h, 16, multiply, sorry, it would be 0.81 of 16 by 0.81, with this we can write this like 16 multiplied by 0.81 square, and keep going, plus 16 by 0.81 cube, so this sum will be equal to 16 times, later I will multiply by 2. 16 that multiply 1 plus 0.81 plus 0.81 square plus, this is a geometric series. So what is the sum? The sum is 16 times this, but this starts in the 1. This is 1 plus r squared plus r to the n, where r is 0.81. So it would be 16. What is the sum? It's 1 divided by 1 minus r. And what is r? Is 0.81. So it would be 16 multiplied by 1 divided by 1 minus 0.81. Or 16 that multiply 1 divided by 0.19. Now this will be equal 16 divided by 1. 0.19 is 19 divided by 10 by 100. So this is 16 by 100 divided by 19. And this result, I have not to forget, is 1,600 divided by 90. I have to multiply this result by 2. So 1,600 divided by 19 is let me see, is 84.21 multiplied by 2 times 84.21, 2 times 4.21 will be 168.42 meters. So he will perform the total distance going up and down of 168 meters. And the result is 152 meters because he didn't take the first step. The ball start here, going down. So we have to subtract the 60 meters going up of the first, to our result, we have to subtract the 60 meters. And now it will be okay. So you subtract here 60 meters, and should be minus 60 meters will be, I suppose, will be 1, 2, 42, 152 meters. Because the problem starts not when I said that it starts at the floor, start up. Okay, this is the result, and we'll go to the next lesson.